Hello and welcome to Synapse. It's again that time of the year when you start thinking about why the bartender added water to your whiskey. Today, we will try to see the chemistry behind diluting your whiskey in the glass. Whiskey enthusiasts would know that adding even a few drops of water in one's whiskey in the glass can enhance the taste and aroma. But why is that so? Before we get into the details of that, perhaps it would be fun to make a quick detour through how whiskey is processed before reaching that glass of yours. If we are making grain whiskey, grains are cooked under steam pressure and then crushed. Barley, on the other hand, is malted. This involves soaking the barley in water for a couple of days, followed by spreading it out on a concrete floor, leading to germination. During germination, the barley releases an enzyme, a chemical if you will, called diastase, which makes the starch in the barley soluble, preparing for conversion to sugars. When mixed later with other grains, this same enzyme processes starch from other grains also. After meshing these grains, yeast is added to the mesh and passed into large tanks for fermentation. Here the yeast attacks the sugar, converting it into alcohol. At the end of this process, we have around 10% alcohol in water. After this, the mixture is distilled, which means that the yeast, the unfermentable matter, the excess water, etc. are all removed from it, increasing the alcohol content to around 70% from the earlier 10%. The distilled alcohol so produced is stored in oak casks for years, which allows air to pass and evaporation to take place. It is during this period that the harsher constituents are removed and the whiskey gets its flavors matured. Evaporation reduces the alcohol content to between 55 and 65%. The whiskey from different barrels is then mixed together. Water is added to bring the alcohol to an optimum strength, and then the whiskey is bottled. The question to address in this video, however, is why further addition of water in glass helps with its flavor. Well, the alcohol component of whiskey is, alcohol, or more precisely ethyl alcohol. What really makes it whiskey are the flavoring agents. There's a vast range of compounds or substances like diacetyl with a buttery aroma, the whiskey lactone from oak barrels giving it a strong coconut aroma, something called acetaldehyde diethyl acetyl which gives it the fruity aroma is generated during distillation. Guaiacol is another such flavoring molecule that provides a smoky flavor to the whiskey. Now, let's get into the chemistry of these flavors. We are going to be talking about the research article titled Dilution of Whiskey, the Molecular Perspective. The link to this article has been provided in the description of this video. In this study, computer simulations were made of alcohol-water mixtures in atomic detail in the presence of one of those flavoring agents we just talked about, guaiacol. This means that they imitated the way molecules or particles, you may say, of alcohol, water and guaiacol behave in the mixture with the help of a computer. As interesting as these computational methods get, we are not going to be looking at them in this video. Here we are going to discuss the amazing results that came out of the simulations. The first thing that was noted was that water and alcohol do not mix at the molecular level. That is, there is a tendency of alcohol molecules to stay near other alcohol molecules and water molecules to stay near other water molecules. This nature of alcohol-water mixtures had been reported earlier. They simulated the nature of this mixture at different strengths of alcohol. It was found that at high strength of the mixture, that is, when there is very little water compared to the alcohol, the effect of water on guaiacol molecule is negligible. But things get interesting as we decrease the amount of alcohol or increase the amount of water, it's the same thing. While at higher concentrations, the alcohol stays in bulk as much as at the boundary. At lower concentrations, alcohol molecules tend to accumulate at the liquid-air interface or the boundary between the liquid mixture and air. As we can see over here, the red and white water molecules are present in the bulk, while the cyan, red and white alcohol molecules want to stay at the boundaries. A closer look would show you that the cyan part of the alcohol molecules, the carbon atom, wants to point towards the air and does not want to interact with the water at all. Following this, the next step was to see where the flavoring molecule, the guaiacol molecules, prefer to stay in the mixture. Above a certain threshold, it was found, about 59% by volume, the guaiacol is pulled into the bulk by alcohol and water. That is, above this threshold, both alcohol and water molecules interact with guaiacol molecules and bring them to the bulk. On the other hand, at lower concentrations, guaiacol prefers to stay with the alcohol near the boundaries that we talked about. Given that it's the boundaries that we taste upfront, it's reasonable to say that the taste of guaiacol and other guaiacol-like flavoring agents is less pronounced at higher alcohol concentrations. The first thing we can infer out of this is that the taste and smell of whiskey can in fact change by addition of water or by evaporation, for example. This also shows that spirits containing other guaiacol-like molecules, like say vanillin, molecule that gives the famous vanilla flavor, ethyl acetate, the fruity flavor in the wines and in perfume sometimes, limonene, the orange flavor, etc., are generally sold at low concentrations, about 30 to 50% volume concentrations. The next thing that comes out of this is the fact that when whiskey is diluted further from 45, the bottle concentration, to about 27% by volume, guaiacol loses its contact with the alcohol, but as much contact is not gained with water. With this, the probability of finding guaiacol molecules in the liquid air boundary therefore increases, as guaiacol does not like being surrounded by water, but after dilution, contact with ethanol is lost. So guaiacol is forced into the liquid air boundary with ethanol on one side and air on the other, of course. Now guaiacol can evaporate easily, contributing to the aroma of the whiskey. Also, the top layer is what comes into contact with our tongue, thus adding to the taste. Thus, the taste of guaiacol and other similar compounds will be more pronounced when whiskey is further diluted in glass. However, it is important to notice that we are not adding in more flavoring molecules. The taste enhancement discussed comes with a reduction in the concentration of guaiacol. To quote the authors of the research article mentioned above, there is a fine balance between diluting the whiskey to taste and diluting it to waste. Though the study was done on guaiacol, chosen to represent a typical taste-giving compound, the understanding of distribution of the solute in alcohol-water mixtures is not limited to beverages. This can find application in pharmaceuticals, given that some formulations are stored in alcohol before addition of water in them. One may want to estimate, if the compounds are more prevalent in the liquid air interfaces or in the bulk before injecting them into subjects. So now, the next time you're out drinking with your buds, you have a cool little story to share. You never know, might impress somebody. Hello and welcome to Synapse. Well, that was all about this episode of Synapse. See you soon with more amazing content. Stay tuned and don't forget to check out our blog.